Hi guys, welcome back. Myself Akshayan. I'm currently pursuing my BA in SSC Bangalore. My topic is the catalog of design pattern. Introduction to design patterns. Design patterns are reusable solutions to common software design problems. They provide a standard terminology and are a way to communicate design ideas clearly. Understanding design patterns enhances code maintainability and scalability. History of design patterns. The concept of design patterns was popularized by the book known as Design Patterns, Element of Reusable Object-Oriented Software. This book was authored by several authors. Design patterns have evolved, influencing modern software development practices. Categories of design patterns. Design patterns can be categorized into three main groups. Those are creational, structural, and behavioral. Each category addresses different aspects of software design. Understanding these categories helps in selecting the appropriate pattern for a problem. Creational pattern overview. Creational patterns focus on object creation mechanisms. They aim to create objects in a manner suitable for the situation. These patterns increase flexibility and reuse of existing code. Singleton pattern. The singleton pattern ensures a class has only one instance and provides a global point of access to it. This pattern is commonly used for configuration management and logging. It's vital implement thread safety if the application is multi-threaded. Factory method pattern. The factory method pattern defines an interface for creating objects but allows subclasses to alter the type of created objects. This promotes loose coupling in the code by eliminating direct dependency on concrete classes. It is useful in frameworks where the exact type of objects needs to be determined at runtime. Abstract factory pattern. The abstract factory pattern provides an interface for creating families of related or dependent objects. This pattern is useful when the system needs to be independent of how its objects are created. It promotes consistency among products by ensuring that the objects created are compatible with each other. Builder pattern. The builder pattern separates the construction of a complex object from its representation. This allows the same construction process to create different representation. It is particularly useful for creating objects with numerous optional parameters. Prototype pattern. The prototype pattern allows creation of new objects by copying an existing object. This pattern is useful when the cost of creating a new instance is more expensive than cloning an existing one. It supports dynamic object creation, enhancing flexibility in code. Structural patterns overview. Structural patterns focus on how classes and objects are composed to form larger structures. They help ensure that if one part of system changes, the entire system doesn't need to do the same. These patterns promote efficient code organization and management. Adapter pattern. The adapter pattern allows incompatible interfaces to work together. It acts as a bridge between two incompatible interfaces, enabling communication. This pattern is particularly useful when integrating legacy code into new systems. Composite pattern. The composite pattern composes new objects into tree structures to represent part-whole hierarchies. It allows clients to treat individual objects and compositions uniformly. This pattern simplifies client code by allowing it to work with complex structures seamlessly. Decorator pattern. The decorator pattern adds behavior or responsibilities to individual objects dynamically. It provides a flexible alternative to subclassing for extending functionality. This pattern sticks to a single responsibility principle by allowing responsibilities to be divided among multiple classes. Facade pattern. The facade pattern provides a simplified interface to a complex subsystem. It reduces dependencies between client and the subsystem, promoting loose coupling. This pattern is particularly useful in simplifying interactions in complex systems. Proxy pattern. The proxy pattern provides a surrogate or placeholder for another object to control access to it. It can be used for lazy initialization, access control, or logging. This pattern helps in managing resource-intensive objects efficiently. Behavioral pattern overview. Behavioral patterns focus on communication between objects and how they interact. They emphasize the delegation of responsibilities and how objects work together. Understanding these patterns is crucial for designing complex workflows. Observer pattern. The observer pattern defines one-to-many dependencies between objects so that when one object changes state, all its dependencies are notified. This system is widely used in event-driven systems. It promotes loose coupling between the subject and its observers. Strategy pattern. This strategy pattern defines a family of algorithms, encapsulates each one, and makes them interchangeable. This allows clients to choose the algorithm at runtime, enhancing flexibility. It promotes the open-close principle by allowing new strategies to be added without modifying the existing code. Command pattern. The command pattern encapsulates a request as an object, thereby allowing for parameterization of clients with queues, requests, and operations. It supports undoable operations and decouples the sender and receiver. This pattern is particularly useful for implementing transaction systems. Conclusion and best practices. Design patterns are essential tools for software developers to create robust and maintainable soft systems. Understanding and applying the right patterns can significantly reduce development time and effort. Continuous learning and practice of design patterns will enhance developers' ability to solve complex problems effectively. This was all about catalog of design patterns. Thank you.